Hey everybody, Mrs. Kroll here. This is going to be a video going through some more topics in section 4.4. Still using that fundamental theorem of calculus, but today we are going to be working on how can we understand the MVT for integrals. So we're going to talk about MVT again. We already talked about it with derivatives, but then how does it change for integrals? And then how do we find the average value of a function? All right, so let's talk about the MVT, mean value theorem for integrals. So what was the mean value theorem for derivatives? Well, it said there was some value C that when we drew the tangent line at that spot, it was equal to the secant line, which was the one that connected the first and the last point and drew them. And so that those two lines had the same slope and that they were parallel to each other. That's what MVT was when we did it for derivatives. So now we're going to do very similar, but we're going to be using integrals. So now we're saying, hey, this area under the curve, which I'm going to use in pencil, all right, all of it. There is some value C that's on the curve somewhere between A and B, that when I look at that point C and I create a rectangle from A to B at that F of C value, that Y value, the area of this rectangle is equal to the area underneath the curve. Exactly. So it's not an estimate anymore like we did with the Riemann sums. This is going to be actually equal to the area underneath the curve. So here is the formula for it. It's right here. And so where does everything come from? Well, this F of C is going to be my height of my rectangle. And B minus A, that's my width of my rectangle. So the area of my rectangle is equal to the exact area underneath the curve. All right, so here's our first practice problem that we're going to do. So take a second to write it down. Find the value of C guaranteed by the mean value theorem for integrals for the function over the given interval of 4 to 9. And the function is going to be the square root of x. So I'm going to use this formula that we just wrote down from the last slide. Okay, so the integral from 4 to 9 of the square root of x, and now be real careful with your notation. We have to have a dx here. That's saying the exact area underneath the curve is going to be equal to f of c, and I don't know what that c value is. That's what I'm looking for, times b minus a, so that's going to be my bigger number minus my smaller number to get the range or the width of that rectangle. So let's go ahead and take the antiderivative. I'm just going to kind of write above this. This is x to the 1/2. So antiderivative is going to tell me this is x to the 3/2 power times the reciprocal of the new exponent, so times 2/3, evaluated from 4 to 9, equals, oh, but what is f of c actually going to be? Well, that's going to end up being the function would be the square root. So the square root of c times 5. So that way that's easier to solve then. So I'm going to go ahead and I'm going to put in 2/3 first fundamental theorem of calculus, 9 to the 3/2 power minus 2/3 4 to the 3/2 power equals 5 square root of c. And now here you can use your calculator for this. It does work out fairly nicely. 2/3 9 to the 3/2 power is going to be 18 minus 2/3 4 to the 3/2 power is going to be 5.3 repeating. and that's equal to 5 square root of c. So I'm going to go up here, and I'm just going to keep working. So 18 minus that 5.33 repeating is going to give me 12.667 equals 5 square root of 3, square root of c, and now we're just going to solve for c. So I'm going to divide by 5. So that's 2.533. And then solving for c, I'm going to take the square that number, and then I will get an answer of 6.418. So at 6.418, if I took that and plugged it in to this function at that height, okay, my rectangle from 4 to 9 width with that height, this value plugged into the function, it would be equal to the area underneath the curve. All right, so we do mean value theorem, and then we also do average value. Okay, I'm just going to zoom in a little bit. This one got a little small when I printed it off. Okay, so this one is saying the average value, my average y value all the way across, what it would be its average. Now, we don't want to go ahead and take every single one of those numbers and add them up and divide by the number that we have, how we would find average typically, all right, because there's an infinite number of points on that orange line that I just drew. So we are going to take the area underneath the curve, okay, and multiply it by 1 over b minus a, or multiply it by 1 over its range. And that will give us our average value all the way across. Because what that's doing is it's taking that actual area and then dividing by the width of the rectangle, and it would leave us with our height, which ends up being the average, overall average value. So it's similar to mean value theorem in the fact that we're trying to find where that average is overall, or trying to find this rectangle here. So that way we can figure out what the height of it would end up being, because that's going to give us our average value. All right, so here's our first problem. So I'm just going to write it exactly how we see it for now. So I'm going to go 1 over b minus a, which is going to be 3 minus 1, and the integral from 1 to 3 of 4 times x squared plus 1 over x squared dx. So 1/2 integral from 1 to 3. Now, I do not want to take this antiderivative. I want to make sure that we are simplifying it as much as I can. So I'm going to distribute the 4 and divide everything by x squared. So this is going to be 4x squared divided by x squared. So I'm left with 4. Plus 4 divided by x squared. Oh, x squared is in the bottom, so I'm going to bring it up to the numerator by making it a negative second power. Make sure you're being really good about your notation. We're still taking the integral, so we need the dx at the end. Now I'm going to take the antiderivative, so this is going to end up being 4x plus to the negative first power, divided by a -1, so this plus is actually going to be a minus here. Minus 4x to the negative first power, evaluated from 1 to 3. Now, I could go ahead and I could put this back in the denominator, which I'm going to end up doing, but I'm going to plug in the values at the same time instead of rewriting it. So this is going to be 1/2, and then I'm going to plug in 3, so 4 times 3 is 12, minus, plugging in 3 to the negative first power is going to move it to the bottom, so minus 4/3. Now make sure you're careful with your negatives here, because now I'm going to subtract from this, plugging in 1, so 4 minus Oh, 4 over 1, so 4 minus 4. Okay, that last part's just going to cancel out. So I'm going to have 1/2 times 12 minus 4/3 is 10.667 minus 0. So I don't need that at all. Divide by 2. Gives me an answer of 5.33. Okay. All right, let's do another one. I'm going to give you a second to copy it down on your own. I would take a second and pause the video. And then when we come back, we're going to go over it together.